It's almost a year now that I have my new old milling machine from Wabeco. Right before Christmas, I needed it a lot for a project, but the machine gave up. More precisely, the motor controller died. At first, the motor ran very uneven, with randomly changing the speed. Sometimes it died completely all of a sudden, but could be reanimated with a firm clap on the milling head. But at some point, even this didn't help anymore. I guess it was just a loose connection somewhere on the controller board, but as I had the plan of replacing the motor with a brushless servo one from China since the very beginning I got the machine, and I already had the motor flying around, I decided to modify it now. Of course, I thought that would be a quick and easy thing to do, but it took me about 3 weeks until the machine was finally running again. That's because the project I talked from will probably publish next Christmas. So until this, watch the motor conversion and hopefully some other things to come in the future. After removing the motor cover, which also hides the control electronics, the washing machine motor is accessible. I'm not an expert, but that looks not that fresh to me. So I removed the motor and, well, look at this piece of German machine building art. Everything's pretty dirty here, so not the worst idea to take everything apart for cleaning and inspection. Uiuiui, I should have clamped the quill before removing the spring. Not sure the carved end mill liked that. As no part on this machine is hardened, there are burrs on every clamping surface where the cutting or clamping forces deform the material. I had to remove them with a hand file before I could remove the quill. With the upper bearing cover removed, I roughly cleaned everything from dirt and grime. I think the belt rubbed against the casting, which produced a lot of rubber dust sitting everywhere. The bearings run a little bit rough, so I will replace them. Removing the bearing and pulley assembly from the housing was extremely difficult without a proper press, but I somehow got it out in the end. After removing the first bearing, you see the ridiculously short shoulder the bearing sits on. I have no idea why they made it that way. Removing the other bearing from the pulley wasn't easy as well. I guess from hammering the unhardened material deformed a little bit, making it very hard to press the bearings out again. With the pulley separated, I cleaned it as good as I could and then took it on the lathe for cleaning up all the surfaces. Here you see the file marks from factory, I guess, around the screw which holds the key for power transmission. I skimmed the non-functional surfaces with very light cuts and cleaned the bearing seats with a fine stone. And doing the same thing on the other side. I protected the freshly rebuilt surface with a few layers of aluminium foil wrapped around the part. And that's the freshly rebuilt drive pulley. Looks just like new, I'd say. Next, I made a new motor pulley. The original one was made out of steel, but given my windy lathe and having to cut relatively heavy grooves and a long keyway, I decided to better make this part out of 7075 high-strength aluminium. And oops, the compound slide hand wheel collides with the lathe tailstock. But fortunately, when I remade the hand wheel and dial a while ago, I prepared exactly for this moment. The hand wheel can be easily removed without affecting the whole bearing and dial assembly. The end of the lead screw has a hex drive built in, which can now easily be driven with a fitting key. A short sanity check with a belt, but it seems to fit quite well. Now I can roughly machine the inner bore, cut the part off on the bandsaw, and finish machine the backside and bring the inner diameter to its final size. The most annoying part was to cut the inner keyway. The aluminium I used is extremely tough and the keyway has to be pretty long. In addition to that, I had no proper tool, as I don't even have a bench grinder to properly grind a high-speed steel cutting tool. So I used a high-speed steel blank just as it was and rammed it into the part for hours until I finally had a little keyway. As it was not very deep, I had to shorten the key. Without a functioning milling machine, I had to do this on my lathe too. The keyway on the spindle motor is so out of center that I had to further adapt the key to fit in. Next, I needed to make a special nut, as there is not enough space for an off-the-shelf one. I started first with making a brass washer for the assembly and then made the steel nut from a piece of C45 steel. And cutting an M12 thread is pretty violent, I have to say. At least with not much space on the machine and short leverage. For driving the nuts, I had to drill 2 holes in the front side. For this, I used the Proxxon IBS grinder and blocked the spindle the Stone Age way with a piece of wood. Since I have the machine, I want to install a proper spindle lock, but just had not enough motivation and time yet. And the Proxxon grinder ran a little bit too fast for the poor high-speed steel drill. And these are the 3 parts for the new motor pulley. Next, I cleaned the rest of the milling head. Everywhere are small metal chips and dust and dirt. The milling head is made out of cast aluminium, even the quill bearing surface. While this is not the best idea, you can clearly see here. Next, I reassembled the pulley again with a set of new bearings. I put the steel pulley in the freezer for about an hour and put the bearings on the heater. With this, it was relatively easy to put the parts together. Only light clapping with a soft hammer was needed. For mounting the bearing in the aluminium housing, I heated the bearing seat up as best as I could with a small heat gun and inserted the bearing. After fitting the bearing in, I realized that the pulley sits a little bit too deep right from factory. That's why the belt rubbed against the housing, grinding a lot of rubber dust away from its side. So I decided to insert a 1mm precision washer underneath the bearing, which raises the whole assembly up by 1mm, giving enough clearance for the belt. Speaking of the belt, I needed a new and larger one, as the motor needs a little bit more space and distance to the milling spindle. For mounting the new motor, I decided to install an aluminium plate on the milling head on which the new motor will sit. As I had no milling machine for machining the plate, I had to get creative and modified my lathe for the needed milling operations. A lathe tool in the forge chuck makes for a large fly cutter to cut away some material from the plate so it fits perfectly to the milling head. That worked astonishingly well. After that, I shortened the part on the bandsaw and drilled 4 holes for mounting the plate on the milling head. As the motor needs a way to adjust it for belt tensioning, the cutouts for the motor shaft have to allow for a slight movement. Without a milling machine, I had to improvise and drilled 2 holes with a hole saw on the drill press a few millimeters apart from each other. Back on the lathe, I had to mill out a recess for the motor, as it has a flange which protrudes about the surface. As I'm limited in one direction of travel, I had to use different milling tools and adjust the position of the part for each tool to reach the whole area where material has to be removed. With that done, I marked and drilled the holes for mounting the motor. They also had to be slotted for adjusting the belt tension, so I drilled 2 holes and milled the material in between away on the lathe. And that's the finished motor mounting plate. Seems to fit quite well. A few countersinks and the part is ready for assembly. I made 4 studs from 20mm steel rod, which will hold the aluminium plate in place in the right height. And now all the parts, including the new motor, can be installed on the milling head. Of course, some nice little chamfers on the part are mandatory. And for a nice and even surface finish, I wiped over the part with an orbital sander. Before reassembling, I also cleaned the quill of the machine. It was also pretty dirty. Looks a lot better now, but I'm not sure about the bearings. I assume some of the WD-40 got into the bearings. They sound a little bit suspicious now in my ears. But for now I will leave it as it is. And the Morse 2 taper of the spindle, which is of course not hardened, looks pretty questionable too. Nonetheless, I remounted everything again and might change the whole milling head someday. And yes, this part was right in there. Before remounting the milling head to the machine again, I cleaned the Z-axis slide at least a little bit. Oh, good not to forget the mounting bolt. By the way, it's just an ordinary hex bolt, no dedicated T-slot bolt, but that surprises me not anymore. And that's the machine reassembled back together with a new motor. The first part to cut with the new drive was a mounting bracket and some stuff for mounting the controller housing to the side of the milling head, as I needed a proper way of mounting the controller in a convenient position nearby the milling head. This motor controller set is way more convenient than the one I installed on my mini lathe a few years ago. It has a potentiometer for speed adjustment and a quick reverse button which can be pressed while the machine is running. The only flaw is that the motor starts on its own when you plug the controller in and the main switch is set in the on position. So that's pretty dangerous. And the motor should be capable of speeding up to 6000 RPM, but the menu doesn't show the chapter 1 to set the maximum speed. It is just not there. But all in all, I'm quite happy with the modification so far, but as said, I might change the whole milling head somewhere in the future. I even have something suitable flying around and waiting. I hope you enjoyed this little episode. Thank you all for watching, and till next.